Welcome to a new set of videos all about answering exam questions for GCSE Chemistry. We're going to start this by looking at some questions on acids. Check out these questions. Feel free to pause the video now to have a go at this question. What we're going to do, we're going to work through one at a time, picking out the key points and where people go wrong. So in this first one states citric acid is a weak acid, and it wants us to explain what is meant by a weak acid, and we are expected here to give 2 marks worth of answers. So in this answer that you can see on the screen, somebody has already given one. It says it is not strong, so will not react well. They are right. Weak acids do not react particularly well because there are less hydrogen ions present, but they have not stated that. They have just stated that it will not react well. So unfortunately, that gets no credit. There are not many particles in the acid. Here, what they are trying to do, they are referencing concentration as opposed to strength. So that would be concentration. The answer that we're actually looking for is the full definition of what a weak acid is. A weak acid does not fully dissociate in an aqueous solution. You could put this doesn't fully dissociate, or you could say that it only partially dissociates. Partially dissociates in an aqueous solution. So that's the definition of what a weak acid is. So that would only probably get us 1 mark, and we are after a total of 2 marks. So how are we going to get that second mark? Well, we've said that it doesn't fully dissociate. We've not said what it would dissociate into. All acids will dissociate into H+ ions and its corresponding anion. So for example, if your weak acid was hydrochloric acid, now hydrochloric acid is typically a strong acid, this hydrochloric acid would dissociate to give H+ and its corresponding anion would be Cl-. In this case, it is asking about citric acid. At GCSE, you are not expected to know the formula of citric acid, so I'm not going to even bother going into it for you. However, what it would expect you to know that all acids dissociate to give a H+ ion. So our first mark is for saying a weak acid doesn't fully dissociate, or that it only partially dissociates. And the second mark is for saying what it dissociates into. And we can cover that by just going into H+ ions. You wouldn't necessarily have to say H+, you could just say hydrogen ions, but you definitely have to have the idea of there being hydrogen and there being ions. That's the first part sorted. Next, a student titrated citric acid with sodium hydroxide solution. Titrations are very important. They come up on lots of papers. They are a required practical, and so is the consequent calculation. This describes a method that somebody used. They have used thymol blue indicator, and it's stated here that thymol blue is blue in alkali and yellow in acid. They've added citric acid from the burette until an endpoint is reached. What's it expecting us to do? This is worth 3 marks. So we've got to say 3 different things, or 3 different ideas, or 2 ideas, and give an explanation of one of those. Let's have a look. Explain what would happen at the end point of this titration. So we're explaining the end point. Refer to the acid, the alkali, and the indicator of your colour. So looking at where the 3 marks are coming from, we're going to basically define what an endpoint is, explain some sort of observation that we would see, and link this into our acid, our alkali, and our indicator. The answer that is written here has got acids are red with the universal indicator, acids are blue, and neutral is green. They have got the idea of a colour change happening. However, they have mentioned universal indicator instead of thymol blue. This automatically means that they cannot get full marks because they have talked about the wrong indicator. But let's not write off this answer yet. Let's see where else they could have get the marks from. So following them on from that, the colour would change when the solution is neutralised. Now that is definitely right. That is an explanation or a kind of a definition of what the endpoint is. The endpoint is when we see a colour change, a permanent colour change. So they do actually get 1 mark for that. They have the idea of the endpoint and the colour changing. They have also built in this idea of some sort of neutralisation happening. So the perfect answer to this question, this one only needs a few tweaks for it to get there, despite the fact they've talked about the wrong indicator. To get full marks here, we do need to say, at the end point, there will be a colour change. First mark. The second mark is for stating that it will go from a blue colour, which is obviously linked to the alkali, and as they are adding the acid, it will go to a yellow colour. First mark, colour change. Second mark, stating what the colour change would be. And a third mark for stating that this will happen when the solution is neutralised. Within this, they will give you a benefit of the doubt mark. If you have stated that it goes from a blue to a sort of greenish colour, then they will accept that as your colour change, because a greenish colour would happen between this blue and yellow. Okay, now it's time to have a go at one of those dreaded titration calculations. Feel free to pause the video now to have a go at this question. Before we look at an example answer, what I'm going to do is go through this question and pick out the key points. I find this is a really useful technique and makes it so you don't have to keep referring back to the question each time. I always tell my students to do this in lesson. Here we go. We've got some volumes of citric acid added to a solution. In the practical, they've repeated it 5 different times. Do not forget, when you're doing a titration, you must repeat the practical until you get 3 concordant results. Now the concordant results are mentioned here. Concordant results are those to 0.1 centimetre cubed of each other. It does state you must use only the concordant results in the table from your calculation. So before we get going on anything, we're just going to get rid of the non-concordant results, essentially the anomalies. This one would be your very rough titration, so that is not concordant. It does not match with those others. We're looking for them to agree to 0.1. These two do not agree to 0.1. These two do, and these two do. So those 3 are fine to use. Those 2 we ignore in this calculation. We are not going to use that. We have removed the anomalies, we've removed the non-concordant results. What we now need to do is state the concentrations and the volumes that we do know to see what we don't know. Through all of this, we are going to be using this formula triangle. Concentration is number of moles over volume, where moles, the unit is MOL. Concentration is moles per decimeter cubed, and the unit for volume does need to be given in decimeter cubed, not in centimeter cubed. So whenever we see centimetre cubed anywhere in this answer, we will need to convert it to decimetre cubed by dividing by 1,000. So let's have a look what this student has done. Now there are all sorts of different ways to lay out your calculations, and realistically it doesn't matter which way you do a calculation as long as you are showing the key points. Most of the time, if you have got the correct answer here, you may get full 5 marks. So if you had none of that but just had the correct answer there, you may get the full 5 marks, unless it says you must show your working. If the question states you must show your working and you do not show it but still get the right answer, you will be limiting yourself to 1 mark. You will only be getting 1 mark for having the correct answer. Despite the fact you might have done the correct calculation absolutely correctly, you will not get full marks if you do not show the calculation stages if it has asked for them. So looking through this calculation, what have they done? Well, they've started by working out the mean titer, which is absolutely great. They've taken the titration values, added them all up and divided by how many there are to get this as their average titer. Now, they have unfortunately left in the non-concordant results. They would get 1 mark for calculating the average, but they have lost 1 mark for not taking out the concordant results. So what they should have done when they were working out the average, they should have removed the non-concordant results and then divided by 3, as there are only 3 results there. Next, they have got these separate volumes here, 12.2 centimetre cubed from their answer there, and 25 centimetre cubed just from the original question. They have forgotten to convert from centimetre cubes to decimetre cubed. So what they would need to do that is just divide by 1,000. What they have tried to do is they have got their volume, they have got their concentration, they have looked up at their formula triangle. They've said number of moles equals the concentration times by the volume, which is completely fine. So this stage of the calculation, despite the fact that they've used the wrong number here, so that should have been the 0.025 moles per decimetre cubed, they have done this stage of the calculation correctly. However, since they have used the incorrect number here, I unfortunately cannot give them the mark for this section. They have then stated that the number of moles of the alkali is equivalent to the number of the moles of the acid. So if there's 2.55 moles of the acid, there must be 2.55 moles of the alkali. And in some cases, that is true. To check whether or not that is right, what you need to do is have a look at any equation they've given you. And if they haven't given you a balanced equation, you must go and balance it yourself. So going back up here, we can see that 1 mole, there's only 1 of those, of your citric acid will react with 3 moles of your sodium hydroxide. So there is a 3-to-1 relationship. So you have to bear that in mind. So 3 moles of that will get you 1 mole of that. To get from there to there, we just divide by 3. So we also have to do that here. So to get from 2.55 moles to whatever the moles of this bit is, they should have divided by 3. So I cannot give them that mark because they have not divided by the correct factor. Moving on from there, they've tried to get to the final stage. They've used their numbers, the numbers that were incorrect. They've seen to get the final concentration, you do number of moles divided by volume. That's their number of moles, which they have incorrectly done. That is their volume that they did incorrectly do. However, we cannot penalise them for making the same mistake more than once. So they have used the wrong numbers, but they've used the wrong numbers correctly. Strange idea, I know. They have done the correct calculation with the wrong numbers, so they do get a mark here. This is what is called an error carried forward mark. where they've done the right thing but with wrongly calculated numbers. So they do actually get that mark there. They've written their answer, and very nicely they have actually rounded it. Now in this question they have not asked you to round it or give it to any significant figures, but it's good practice to do that. They've written the full answer that came up on the calculator there and then simplified it down. Whenever possible, if you do have time, it is worth writing it down to at least 4 significant figures to show the examiner that you have calculated it properly, but then also that you can simplify that down correctly. So this question, they have done bits wrong, but they have also done bits right. So as a total, they would get 2 out of 5 marks. I'm going to use the section that we started with earlier. So I have already taken out my concordant results, and I'm going to calculate my mean volume. Within this, I am going to write a little bit more than what you'd be expected to write in an exam question, due to time constraints. So my mean volume of my acid, it's going to be my concordant results divided by 3. So add them all up. Divided by the 3. When I do that, I get 12.13 recurring centimetre cubed. Do not forget, whenever you have a titration calculation, all volumes must be reported in decimetre cubed, and I get to decimetre cubed by dividing by 1,000. So this is my mean volume of my acid. Let's have a look what other numbers I have from the question. Now in the question, it did state the concentration of my alkali was 0.102 moles per decimetre cubed. So what I'm going to do is just make a note out of that fact. So my alkali concentration What other facts do I know from the question? Well, from this part of the question, it doesn't state a volume. However, if we have a look back to the second part of the question, it did tell us how much of the sodium hydroxide was added. A big thing in these exams is information from previous parts of the same question can be used in consequent parts. So it is expecting you to look back to the rest of the question to find out some numbers that you need. So it's 25 centimetre cubed of my alkali. So my alkali's volume, 25 centimetre cubed. Convert it to decimeters by dividing by 1,000. There we are. So I have got my concentration of my alkali, my volume of my alkali. Now I need to get the number of moles of my alkali. To get moles, we do concentration times by the volume. So I'm simply going to do that concentration times by that volume. When I pop that into the calculator, I get 0.0025. You can pop in my units there as well, just for completeness. So 0.025 moles of my alkali. We saw when going through the student's answer that they did not account for the fact that 3 moles of the sodium hydroxide reacts with 1 mole of the citric acid. And what I did before is I had to take those moles and then divide them by 3 in this case, because 3 moles of the sodium hydroxide gets you 1 mole of the citric acid. So moles of the acid, it is the moles of the alkali, divided by 3, which gets me 0.00085. I have now got the moles of my acid. From the first part where I've answered, I have got my volume of my acid. I'm going to have to pop these together to get what my concentration of my acid would be. So the concentration of my acid, using the formula triangle, it's moles over volume. I'm going to do the 0.00085 divided by my 0.01213 decimeter cubed. When I do that, I get 0.0701. My units would be moles per decimeter cubed. And that is the answer that you are expected to give. As a sort of common sense double check, it is always worth comparing the concentration that you get to the original concentration stated. In theory, the concentration of our acid and an alkali should be similar. Not exactly the same, because we can see here that there are more moles of the sodium hydroxide than of the alkali, so we'd expect the concentration of the sodium hydroxide to probably be higher. So this number will be similar to our number, but this one will be a little bit higher. Let's compare it. Yeah, those results are not too far apart. So that's just a sort of common sense check for if your answer makes sense. That's it for the titration question and our acids and alkalis question. I hope you have found this useful, and I hope my awful editing skills have not put you off too much. I have learned a lot putting these videos together, so hopefully the next few ones will be even better. Keep your eyes peeled, there are more videos coming soon going through more exam questions. Be gone, minions of science, be gone!